So now that you have reviewed the anatomy of the heart and the cardiac muscle cells and the blood flow and all of that good stuff, action potentials of the cardiac muscle cell, we're going to start talking a little bit more about some other ways that the heart is manipulated. Um, we're going to, as we start into these cardiovascular drugs, it's important to note that this many have a kind of complex way that they work. And so you're going to have to kind of dig down in this and really look at how they work. It's pretty fascinating, but it has a lot of detail to it and it can be kind of confusing. So we're going to start off in talking about the autonomic nervous system in order to understand these drugs a bit better. Also, in practice, it's very common to prescribe several of these drugs, and the veterinarian's responsibility is to make sure that they are compatible and appropriate for the particular animal. But you will sometimes be explaining things to the owner, so you do have to have a level of understanding about them. And it doesn't hurt if you look up the drugs and refresh yourself on them and make sure that everything being used together is a good thing. Um, and you might have to warn owners of different sorts of signs that might occur with using a couple of these drugs. Um, and because we're typically treating a sick heart, some drugs are not appropriate to be used for certain kinds of cardiac conditions. So, because it can affect what goes on in the heart. So you're kind of the second check here. But also, I think the major thing that you're going to do is after you hand these drugs over to an owner, you're going to be doing the callbacks. You're going to be calling them back in a day or two and asking them how the animal is doing. And you need to be able to pick up on certain signs that the owner, clinical signs that the owner may tell you about, and realize that they are um, something that needs to be noted with regard to the type of drug that the animal is being given. So, um, so I want you to, if you don't have the book in front of you, go and get the book. Put this on pause, go and get the book because we need to look at something together. Okay, hopefully you got the book and you're going to be flipping to the end of chapter 5. At the end of chapter 5, and it's on page 139, is a list of drugs. So in this lecture, we're going to, and by this I mean this particular section, we're going to be talking about antiarrhythmic drugs, and there's a list of them underneath the antiarrhythmic drug heading. So we're going to be getting into the sodium influx inhibitors, the beta blockers, and some other antiarrhythmic drugs. And so we'll talk about what an arrhythmia is in order to talk about how we're going to counteract it. And then we're also going to talk about positive inotropic drugs and inodilators. And there's a list of those in there too. So very important to always look at the end of the chapters from now on for these lists of drugs. I think if you start thinking in terms of what the names are, um, that is going to help you to recognize them. Some of the drugs will be in families where they have a consistent ending of the drug name. So the suffix of the drug will help give away what it is. So you're going to need to know that. You're going to need to know these names as they are listed here. These are typically not trade names. They're typically the generic names for many of these drugs at this point. So really important that you start to look at that. So we're going to first talk about the autonomic nervous system in order to understand how these drugs work. So if you remember, we had the sympathetic nervous system, part of the autonomic nervous system, and the neurotransmitters for those are, if you remembered, epinephrine and norepinephrine. Those are the neurotransmitters for the sympathetic nervous system. For the parasympathetic nervous system, the neurotransmitter is acetylcholine. Acetylcholine is that neurotransmitter. So you need to know these because we're going to be talking about them. So commit them to memory, put them on a flashcard, and start your stack. So both of these systems, if you remember, they work simultaneously, but whatever is going on with the animal is going to drive which one is stimulated and which one is in more control. So the sympathetic nervous system, also known as the fight or flight um, nervous system. Let me kind of move my frame here a little bit. It is, because it is the fight or flight, the effect it has on the heart rate and force of contraction is it increases both of those. So the animal can run away or turn and fight something. The blood pressure is going to be increased when the sympathetic nervous system is stimulated. Peripheral blood vessels, we're going to get the blood being shunted away from things that do not need to have blood going to them at that moment. And so in particular, that's going to be, sorry, I'll move my little frame here again, the gastrointestinal system tract, GI tract. So we're going to move the blood away from that. We're going to move it away from the skin. We're going to, that'll hopefully help us if we get cut by something in our fight or our flight, and we'll have less bleeding. But we're going to shunt it also away from the kidneys. If you remember, that was one of the effects we talked about in the last chapter that can happen with stimulation of the sympathetic nervous system. So our main goal is to get it to the blood, to the brain, to the muscles, so that we can run away or fight something. And then the bronchioles. If we're running away or we're fighting, we're going to need more air. And so we're breathing harder, and the bronchioles are going to dilate. So that's the effect of the sympathetic nervous system on the bronchioles in the lungs. And it's just to drive an animal's ability to be able to run away or fight in a crisis situation. So when we talk about the sympathetic nervous system and the neurotransmitters and the receptors, they are called the adrenergic or catecholamine receptors. And the adrenergic are the ones in the sympathetic nervous system. And when we have a drug that is going to stimulate the sympathetic nervous system, they're called adrenergic agonists. If you want to think about the adrenal gland, this is where the epinephrine and norepinephrine are released from. So that's why they're called adrenergic. If it antagonizes the adrenergic receptors, they're going to be called adrenergic antagonists. So they're going to either block the receptor itself or change the receptor's conformation so that they can't be stimulated by epinephrine and norepinephrine. And we're going to talk even more specifically about these adrenergic receptors that are alpha 1s, alpha 2s, beta 1s, and beta 2s. I don't know if you got into those, but we're going to talk about them very detailed. So the adrenergic receptors, the beta 1s, they're located in the heart. And they're located in the cardiac muscle cells, and they're going to stimulate the heart rate and the force of contraction. So that's where they're located, and that's what they do. If you want to think about beta 1s are responsible for beat, and the beat of the heart, both the rate and the force of contraction, that would be a good way to remember it. The beta 2 receptors are located in the bronchioles, and they are going to dilate the bronchioles, allowing more air to get into the lungs and for the animal to breathe, which is necessary for running away or fighting. And alpha 1s. So alpha 1 adrenergic receptors are in the peripheral blood vessels. They're not in the major vessels, they're in the smaller ones, kind of precaprial and precapillary, I should say. And what they do is they're going to restrict blood flow to the skin and shunt it to the major organs of the body that are necessary for running away and fighting. And so they cause vasoconstriction. These are the blood vessels that get constricted when we have a circulatory problem, and when you are pressing on the mucous membranes to watch for, they'll blanch, and then they'll, in the mouth, you're going to press on the capillary, the mucous membranes to look at the capillary refill time. And these are the ones that are affected when we have a lot of sympathetic nervous system stimulation, but it's basically shutting down those capillaries, or the blood flow to those capillaries, so that it prolongs that refill time. So the sympathetic nervous system is stimulated. There's something going on there. We're not getting good perfusion when that happens. So, and then lastly, let me go back here to the alpha 2 receptors. We're not going to talk about manipulating them much with cardiovascular drugs because they have to do with release of norepinephrine, and they regulate release. You'll talk about those more when you get to your anesthesia class. So it's interesting to understand that not everything stimulates the uh, sympathetic nervous system to the same extent. So epinephrine, which is a naturally produced hormone from the adrenal glands that is the actual neurotransmitter of the sympathetic nervous system, it reacts with both alpha 1 and beta 2 receptors, but it reacts with them differently. It reacts more, stimulates more the alpha 1s, which cause that vasoconstriction. And so we use that property in a local anesthetic. It's combined with lidocaine that's used as a local anesthetic, and it will constrict the blood flow in those areas where it's injected and allow the lidocaine to stay in that area and have its local anesthetic effect for longer. It also will react with beta 2 receptors, but not as much. So it really doesn't have much of an effect on those beta 2 receptors in the bronchioles. And so ideally, we want to select drugs and neurotransmitters that have the effect on the receptors that we want, with a restriction of the receptors that we don't want. So you'll see that we're going to talk more about the drugs that have the effect that we want because they affect just the receptors that we want to affect. So the parasympathetic nervous system, it has the opposite effect in general of the sympathetic nervous system. It doesn't have a lot of effect on that peripheral blood flow. These are cholinergic receptors that are in the parasympathetic nervous system because acetylcholine is the neurotransmitter. And those drugs that are that do counteract, that are the antagonists of the parasympathetic nervous system, are called parasympatholytics. Those that mimic the parasympathetic nervous system stimulation are parasympathomimetics. You could use these terms in the sympathetic nervous system too. Sympatholytics will counteract the sympathetic nervous system. Sympathomimetics mimic the sympathetic nervous system. So you need to be familiar with all of these terms. So when the parasympathetic nervous system is stimulated, we're going to decrease the heartbeat and contraction because an animal is going to be resting and restoring. The blood flow to the gastrointestinal tract is going to be increased because we're going to be digesting, and the bronchioles are going to be constricted because we don't need to breathe hard in order to just rest and restore.